Alright, in this video we are going to take on a little bit of a tougher question, a little more of a challenge question. Just see how things can link together and see what we figure out. So here's the scenario, a horizontal angle type question. So suppose we have, it doesn't matter what it is, suppose we have like a rope or something like that, and at the end of it, let's put a timbit, chocolate timbit on the end of it, something like that. Alright, so there's our chocolate timbit at the end of a string or something like that, and of course it is whipping around in a horizontal circle. Now, let's say that this is 0.72 meters long, and let's say it's going around at 0.85 hertz. What we're going to do is we are going to see if we can find the angle. Okay. Now, this angle, of course, is shared by the forces as well as the radius and the length of the rope and all that kind of stuff. I'm going to see if we can actually find the angle. Now, we can't find FG because we don't have mass. We can't find mv squared over r. We don't have the radius. We don't have the mass. We don't have the v. There's a bunch of things we don't have. So we're going to see if we can start. We're going to have to tie things together right from the start and see what we can do. Now, seeing as I am looking for the angle, I might want to start with something that actually involves the angle. And of course, the angle is actually created by the forces. So let's see if we can work with that. Let's type thing 4 where, we got FC is down here, FG is over here. If we just use tan theta, we can incorporate the forces. So FG over FC, and of course mg divided by mv squared over r. Once masses cancel out, and we're left with rg divided by v squared. We've done this type of thing before. Now the thing is, we don't have the radius, we don't have theta, we don't have the v, so there isn't much we can do with this. But one of the old expressions we have for v is equal to 2 pi rf, and this might come in handy because I am given the frequency, so it would be nice if I could actually incorporate that. So I'm going to substitute the v with 2 pi rf, and of course it's squared, so I'm going to square everything inside of it and see if that helps me out. So if I do that, I'll get the r and the g in the top, and I'm going to square all of this. That's going to give me 4 pi squared r squared f squared. Now, as soon as I do that, one of the radii cancels out. So this guy cancels out this guy, and I am left with g over 4 pi squared r f squared. I know g, I know 4, I know pi, I don't know the radius, I do know the frequency. So I still have the theta I don't know, and the radius I don't know, so I still can't solve it. But let's see what else I can do. I do have the length, and I can incorporate the length with the radius, because of course the radius would be the length times cos theta. So if I can replace this with this, I can incorporate the other measurement I'm looking for, as well as the angles in there as well, but I'm looking for the angle. So I'm going to substitute that in there, and I have g. I'm on the denominator, I'm going to have 4 pi squared. My radius, I'm going to switch it for L cos theta, frequency squared. Now this looks like just a big mess of stuff, but we're going to work with this, and if we do a little check, g I know, 4 I know, pi I know, length I know, cos theta I don't know, f I know. The only thing here I don't know is the angle, and the same thing over here. So now I'm down to one unknown. I should be able to solve it. Now, of course, this is tan theta, this is cos theta, so they don't really match up. But I can rewrite tan theta because when the old trig identities, tan theta is equal to sine theta divided by cos theta. And if I do that, I can sort of move that over here. That's going to be sine theta divided by cosine theta. It's perfect because then our cosine thetas can actually cancel out, both in the denominator, and all I'll be left with is the sine theta. So this cos theta is going to cancel out that cos theta, and I'll be left with sine theta. Everything else left over here I know, and that is the only thing I don't know, and I have to solve for sine theta. So I'm going to rewrite this because it's looking kind of ugly. Sine theta equal to g divided by 4 pi squared. Still have the L, and then f squared. Okay. Well, I know all of this stuff. I can plug in all my values for this, and I can inverse sine it and get my value for theta. So put all the values, inverse sine, get an angle of about, give or take, 29 degrees. Again, this is a fancy type, more complicated derivation type question, but it sort of shows how some of the ideas can link together, a bit of a challenge type question, and shows how you can actually solve it. Mass is a typically thing that you have, or radius is something you typically have, so it's kind of nice to try a question like this and see how things can link together and actually come together to find the theta value.